Imagine you're looking at a family photo album, but the first few pages are completely blank, and then suddenly, you find a picture of a fully grown adult. That is exactly what astronomers are experiencing right now with the universe. We thought the early cosmos was a slow, messy process of gathering dust and gas, but the James Webb Space Telescope just showed us something impossible. It turns out, the universe didn't just wake up. It hit the ground running with massive, bright galaxies that shouldn't exist according to our best theories. Today, we're diving into the mystery of the cosmic dawn and why our current models of reality are looking more like a messy sketch than a finished masterpiece. Welcome to Sci Nova, where we explore the edges of human knowledge. To understand why we're so confused, we first have to understand the dark ages of the universe. For hundreds of millions of years after the Big Bang, there was no light. There were no stars, no planets, and no one to see them. The universe was just a vast, cooling soup of hydrogen and helium gas. It was a period of profound silence and darkness, waiting for something, anything, to ignite the first sparks of light. This period is what we call the prelude to the cosmic dawn, the moment the first stars finally flickered to life. The cosmic dawn is the era when the first generation of stars ignited, fundamentally transforming the cosmic environment. These weren't your average stars like our sun. These were the true pioneers. As they ignited, they released intense ultraviolet radiation that began to ionize the surrounding gas, effectively clearing the fog of the early universe. This process changed the very chemistry of space, setting the stage for everything we see today. It was the universe's first real sunrise, a transition from a dark, neutral state to a luminous, ionized one. But here is where the story gets weird. Enter the James Webb Space Telescope, the most powerful eye ever pointed at the heavens. While previous telescopes like Hubble could see the nearby universe, JWST was specifically designed to peer through the cosmic dust and look back in time using infrared light. It is the primary instrument we are using to study this cosmic dawn era. By capturing light that has been stretched across billions of years, JWST allows us to see the very first light signatures from the dawn of time. It's not just a telescope, it's a time machine that is currently breaking our brains. Before JWST, our models of galaxy formation were quite confident. We believed that gravity would slowly pull gas together, forming small clumps, which would eventually merge into larger, more complex galaxies over billions of years. We expected the early universe to be populated by small, chaotic, and relatively dim star clusters. We thought we had the timeline down perfectly, a slow buildup, but the data coming back from JWST is telling a completely different story. It's not a slow build, it's an explosion of complexity that we never saw coming. The shockwave hit the scientific community when JWST discovered a surprisingly large population of massive galaxies existing less than 300 million years after the Big Bang. Think about that scale. In a time frame that is practically a blink of an eye in cosmic terms, these galaxies were already fully formed, massive, and incredibly bright. According to our old models, there simply shouldn't have been enough time for gravity to assemble such huge structures so quickly. It's like walking into a nursery and finding a group of toddlers who are already 6 feet tall and working corporate jobs. It just doesn't fit the timeline. The data is even more staggering when you look at the redshifts. Astronomers have observed high abundances of galaxies and active galactic nuclei, or AGN, at redshifts Z approximately 9 to 11. For those of you not fluent in astrophysics, redshift is how we measure how far back in time we're looking. A redshift of 9 to 11 means we are seeing these objects as they existed when the universe was incredibly young. Finding a high density of both galaxies and supermassive black holes, the engines behind AGN at these levels suggests that the early universe was much more active and crowded than we ever imagined. It's not just that there were more galaxies, it's that they were much brighter than expected. JWST has identified roughly 300 unusually bright cosmic objects that defy our standard evolutionary tracks. These aren't just small smudges of light, they are powerful, energetic structures. This abundance of light at such an early stage suggests that star formation was incredibly efficient. Or perhaps that the first stars were far more massive and energetic than anything we see in the modern universe. We are looking at a cosmic era that was much more high-octane than our simulations predicted. And then there are the monster stars. Through chemical fingerprints captured by JWST, astronomers have begun to identify these gigantic primordial giants. These aren't just big stars, they are monsters that likely lived fast and died young. These first-generation stars, often called population 3 stars, were made of pure hydrogen and helium, lacking the heavier elements like carbon or oxygen that we see in modern stars. Because they lacked these coolants, they could grow to hundreds of times the mass of our sun. They were the heavy hitters of the early universe, and they were responsible for seeding the cosmos with the first heavy elements. To put this into perspective, let's look at the timeline. We've observed a supernova occurring when the universe was only 730 million years old. A supernova is the explosive death of a star, and seeing one that early tells us that the first generations of stars had already lived their entire lives, burned through their fuel, and exploded. This means the cycle of stellar birth and death was already in full swing very shortly after the Big Bang. The universe wasn't just starting up, it was already cycling through life and death while it was still in its infancy. What does this all mean for our understanding of physics? It means our standard model of cosmology is incomplete. We have these redshift observations covering more than 13 billion years of evolution, and the beginning of that timeline is much more chaotic than our math suggested. It suggests that either gravity works differently in the early universe, or that there was some other mechanism, perhaps dark matter, interacting in ways we don't understand. That accelerated the formation of these massive structures. We are essentially back at the drawing board for the first chapter of the universe's biography. The mystery of the cosmic dawn isn't just a problem for astronomers. It's a beautiful reminder of why we do science. Every time we think we've mapped the territory, the universe reveals a new, unexplored continent. The fact that JWST is breaking our models is actually the best possible news. It means there is still something profound to discover. Something that will fundamentally change our perspective on where we came from and how the cosmos came to be. The messy sketch is being replaced by a much more complex, much more vibrant reality. As we continue to process the data from the James Webb Space Telescope, the picture of our origins will only become clearer and likely even more surprising. We are living in a golden age of discovery, watching the first light of the universe finally come into focus. The cosmic dawn is no longer a dark mystery. It is a bright, energetic, and slightly chaotic beginning that is teaching us how to be better scientists. The universe is far more wild and wonderful than we ever dared to dream. If you want to stay on the cutting edge of these cosmic mysteries, make sure to hit that subscribe button and turn on notifications. We're tracking every new discovery from JWST and beyond right here on SciNova. What do you think? Is our model of the Big Bang fundamentally wrong? Or are we just missing a piece of the puzzle? Let us know in the comments below. Thanks for watching, and keep looking up.